This is page 37 in module 4. And I know in the book it says to order from least to greatest, but we're just going to focus on converting these to, or just estimating the value of each expression to the nearest tenth. Okay, so let's read this right here. So to locate the approximation of a square root on a number line, identify the two closest perfect squares, which was one greater than the radicand and one less than the radicand. So if you haven't looked at the lesson video for page 36, please go ahead and do so before you move on to this page. So we have, let's consider this first one. I numbered them all 1 through 4. So this is square root of 8. So your first task, or if you remember, you would just put that in the middle. So radical 8 would be in the middle. And you would just find the square root or a perfect square that's closest and smaller than 8. Would be, it won't be 7 because it's not a perfect square. It won't be 6. It won't be 5. It will be 4, square root of 4, because square root of 4 is 2. We know that the 2, which is the same whole number, 2 times 2 would give you 4. So that's the closest perfect square that's smaller than radical 8. So that's going to be 4 square root of 4. And we also need one that's greater than this radicand. So it's going to be square root of 9. And 9 is a perfect square, okay? So square root of 4 is same thing as 2. And square root of 9 would be 3. So we know that it's going to be in between 2 and 3. So this answer, the estimation, is going to be in between 2 and 3. But since we know that 4 and 8 has a difference of 4, 8 and 9 has a difference of only 1. So we know that the estimation would be closer to 9, so closer to 3, okay? So it's going to be not in the middle like 2.5, it's going to be more slightly towards to the right here, so it's going to be 2.8, okay? Let's do the next example. We have square root of 91. So your first task is to put that in the middle, so square root of 91. And we find the two perfect squares that are one's less than and one's greater than. So square root of 81 would be a perfect square because we know that 9 times 9 is equal to 81. And we know that 10 times 10 is equal to 100. Okay, so when you solve, this is 9. The square root of 81 is 9. Square root of 100 is 10. We know that this is, it has 10 difference, it has 9 difference. It's like about the same, so it should be in the middle. So I put 9.5. Okay. Note, remember this squiggly line symbol is called, it's an approximation or about or around. So it's about 9.5. Number 3, so it's radical 70. So you would put that in the middle. You find the two perfect squares that are less and that are more. So perfect square would be 64 because we have 8 times 8 for 64, and 81 would be 9 times 9. So we know that radical 70 is in between 8 and 9. And this has 11 difference, this has 6 difference, so it's closer to 8. So it's like about 8.4. It doesn't have to be exact, it's about around there, okay? Number 4, it's radical 45, so you'll put that in the middle and just find two perfect squares, which is 36 for 6 and 49 for 7. Okay, so we know that it's in between 6 and 7. And since the difference between these are less than these, it's 6.7. It's closer to 7. Moving on. It says solve each equation, round your answer to the nearest tenths. So we can use a calculator for these, okay? So this one was just estimating. So without using a calculator, of course, if you just plug this in a calculator, they will tell you the answer. But this was just an estimation without using a calculator. For these ones, you could use a calculator. So let's see, number A, letter A, it's x squared is equal to 25. to get rid of or to cancel out the squared is by putting the square root. Okay, this squared, this right here, squared, to cancel it out, the inverse of it, you would just do a square root. So square root of x squared means it's x is being multiplied by twice. So what two numbers or what two variables multiplied to get x squared? It's x, right? X times x is x squared. So on the left side, you would get, oh, let me just delete this. On the left side, you would just get x because square root of x squared is x. And square root of 25, so whatever you do to the left side, you have to do the same thing to the right side because they're equal to each other. You have to keep them balanced. So 25, so square root of 25 is 5 because 5 times 5 is 25. Okay, so the answer, x is equal to 5. That was easy because it was a perfect square. And a squared is equal to 13. So we would just put the radical above both. So we have a times a is equal to, a times a is equal to a squared. So the square root of a squared would be a. So a is equal to radical 13. So using a calculator, you push down the radical sign in the calculator and put 13 in it. You would get a is close to 3.6. And for c, same thing. C squared is equal to 80. So we can say c by itself is equal to radical 80, square root of 80, okay? And so when you plug it in a calculator, you'll get 8.9. And for d, g squared is equal to 53. So just to get g by itself, not g squared, you would just have to put a square root of over 53. And if you put it in a calculator, you'll get 7.3.